from now on, everything that you see and everything you hear will be recorded, and you can go back and review that when you would like, which, of course, will be soon. Every day, right? Okay, now, so when you go to Blackboard and you get those tabs, that second grouping down there, handouts, PPTs, and more, like I said, the link to the YouTube videos would be first. And when you click on those YouTube videos, you'll see just a whole list. And the ones at the top are the oldest, the ones at the bottom are the newest. So the one we do for today, it will wind up at the very bottom. Okay? Now, let's see. I guess that's all I need to do. One thing I didn't ask. I asked about the locator card, the research paper. Now, please, folks, there is a research paper due. Read those instructions, okay? The instructions for the research paper are there under handouts, PPTs, and more, right under the YouTube video link. So read that. But go to that first video that talks about syllabus. I believe that's where it is. Or maybe it's the second one if it says research. Anyway, go there and listen to what I say about that, because that's I'll probably fill in a few gaps that are missing on the written instructions, or at least I go into it ad nauseum to tell you about it. So please don't ignore that. Get started on it early, as in this week. Pick a topic. You can change it if you want to, but pick a topic, start looking for it, try to get it done. Not due till the end of the term, but don't wait till the end of the term to turn it in. Okay? And you'll hear that if you listen to the video. And I do this, so in case any of you don't or don't read it, if you turn it in during the month of January, you get 4 bonus points added to your score. Turn it in the month of February, 3, March, 2, and the first 2 weeks of April, 1, and only 1 bonus point. Okay? If you turn it in the last 2 weeks of April, that's right before finals start, at the end of the term, you just get your score. Okay? So, please, get working on the paper early. All right. So the research instructions are there after the YouTube video link. Then all the PowerPoints that we will possibly do in this course. We probably won't get them all done, but all that we could possibly do are there. And they're in static form. Okay? You'll see later when I teach, I use the PowerPoint, so you'll hear me, or see me write on them, that kind of stuff. Those are active form. That's under the YouTube videos. You'll see a second place for the PowerPoints there. Okay? And then, after you go through all those PowerPoints, scroll, finally you get to a series of websites that students, that either I found or students have found that said they found helpful for the course. You can use those or not. They're completely up to you. They're just there for your benefit and viewing pleasure, whatever you want to do with them. Okay. Is that all that's there? I believe it is. All right. Do any of you need to see any of that right off the top? Okay. Now, there's another thing that I do usually on the first day when I wasn't here last time, and that was safety. That's all out there, either on that first or second video. If the first video says syllabus, that's where it starts. The second one says research or safety, that's where it starts. So listen to that video as well. Now that one I think I did when we were in this room. So the safety issues for this room are a little bit different from the room down the hall. And I do not see, there's not a emergency escape route type things on the wall over there. I can't see it. Okay. Yeah, this room doesn't have one. But basically, in case of fire, we go down and out the building, we go out the front, and whichever the exit doors are right here, so go down and out the building to that front parking lot, okay, the one facing the hospital, okay. This building has 2 fronts, so I don't know which one you come in, but the one facing the, not the interstate, Western Superhighway. And in case of fire, of weather emergency, you go down an interior, okay. So in that case, we go down to the first floor and any interior space that doesn't have windows. Now the hall would be okay except for the glass doors, so you have to get into the hall where you can close off the doors, okay? So anyway, that would be where you go there. And then active shooter, I do some talking about that. This room is a lot harder to defend than the others because I can't lock the door from the, I can't lock the door, period. So there's no way to keep them out. So what we do, we get behind the concrete wall here in the corner, everybody back there, quiet as possible. First place, someone has dialed 911 or, and by the way, here's a good thing to do. On the door I come in the morning, okay, coming off this parking lot here, and I think probably some other doors, there's 2 phone numbers listed for campus police, Bessemer campus and Birmingham campus. Get those numbers down, at least if you're on both campuses, get them both, but if you're on the Bessemer campus only, put that in speed dial on your phone so if an emergency did happen, you can just hit that and get campus police. If you don't have that number on speed dial, 911 will do, okay? So first thing we'll do that, and then everybody shuts off their phone because we don't want it ringing when he walks down the hall, okay? So there's not much we can do. The door opens outward. There's just not much we can do. So y'all get back there. If he should come in, none of you be a hero. I'm not going to be a hero, but my life's back here. Yours is in front of you. So if anyone has to deal with them, it'll be me, okay? So hopefully that won't happen. It hasn't happened anywhere in the state of Alabama that I know of. Only one community college, I think somewhere out west somewhere, it happened one time. Okay, there's been an active shooting. Now, several of the big universities have had them, but so far, knock on wood, only one community college, and nowhere close to here. Not that funny. Okay, now, all right. So, any questions on anything? That's all on those YouTube videos, so watch those so I don't have to go through that. Any questions? All right. Now, if you needed to see any of it, I brought the flash drives with that stuff on it, but if you don't have any questions on that, let's get ready for pre-calculus algebra. About time, huh? Whoa! Yeah, okay. It's going away. All right. Now, Math 112. I usually have this set up beforehand, but today was strange, of course. First week is always strange. All right. Start the slideshow from here, from this current slide. Now, just a little bit of background first, and I go over this in the YouTube video when I'm talking about the syllabus. Here's the book, and by the way, it is a Cengage book. Do y'all all know about Cengage Unlimited? You don't. Okay, this publisher, first one that I know of to do this, has come out with this deal that if you purchase for about 120 bucks, which sounds expensive, but any class you have that term that uses a Cengage book, you have access to it. That is access to the e-book, not a physical hard copy book. If you want a physical hard copy book, you can then rent the book for only something about $8 or so. They may have gone up, but that's what it was, I think, last term. So it's really a pretty good deal monetarily. You know, it saves you some money, but, you know, it's either you're using an e-book or you rent the book. Now, have any of you gotten access to the book yet through Cengage Unlimited? Last term, they required that I have WebAssign set up before you could access the e-book. Now, if that's the case, I still have that to do, okay? And I'm going to try to get it done hopefully this week, okay? And even though this is on the syllabus and everywhere else, let me tell you about my office hours. This term I've wound up teaching 10 classes, okay? I'm supposed to teach no more than 4, okay? So it's a pretty heavy load, but just by every term, seems like it turns out this way. So I have very few office hours. The office hours I do have, the biggest chunks, Monday and Wednesday mornings, 8 to 10. I actually had another class then that I was able to give to somebody else. Nice. Okay. So 8 to 10 on Monday and Wednesday mornings, 2 chunks of office hours. Okay? On Monday in the afternoon from 3:45 until 6, there's another decent chunk. A little bit bigger chunk even. And then on Fridays from 8 to 12, but then I'm on the Birmingham West Campus most days, most Fridays. There are at least one Friday coming up that I know I have math meetings in Tuscaloosa, so I won't be there. It's the first Friday in February. And then I don't know when this is going to be, but usually at least once a term, I have a mild form of leukemia, so I'll have an infusion probably one Friday. So I'll let you know when that's coming up. So that's my biggest chunk of office hours. Now, the other thing is they love calling meetings on Fridays. So there may be some Fridays I'll be in meetings, but if I know about it ahead of time, I'll let you know so you can schedule if you do need to come see me on Birmingham West Campus to do that. Now, that's about it, folks. Now, on Tuesday and Thursday, 8 to 8:30 in the morning. Before this class, you can catch me. My office is down at 265. That's down. Y'all all know where the orientation classroom is? Right across the hall from that. It's 265. Okay? And that's my office. And let's see. The other times on Tuesday and Thursday, I have back-to-back-to-back classes. The third one gets out at 12, 8:30 to 9:45, 10 to 11:15, 11:30 to 12:45. So from 12:45 until 1:15, I have a half hour there. I'm in my office then, probably cramming down lunch as fast as I can, but I always eat in my office, so you're welcome to come see me if you don't mind seeing food fall around. Okay. And then at the end of the day, and I have in the afternoons on Tuesday and Thursday, I have a mini-term physical science class, both the first mini-term and second mini-term. Starts at 1:15, the class goes until 3:45, then the lab goes from 3:45 to 5:45. So I have a big 15 minutes at the end of the day, 5:45 to 6. So you can see me then too. And I'll stay after 6 if there's anything you need, because I just don't have many other office hours. So Tuesdays and Thursdays, half hour in the morning before this class, half hour at lunch, and 15 minutes, a half hour, whatever it takes at the end of the day. Okay? Now, that's except for, oh my goodness. Okay. I just realized I was supposed to have been on the help desk this morning at 8 o'clock. I signed up for it and I forgot to do it. Shame on me. Someone slapped my wrist. Oh, never mind. Okay. I'll be there for the last 15 minutes today if I can remember to do it. From 5:45 to 6, I'll be there. I was going to say except for Thursday, but it's not Thursday. It's today. I blew it. Okay. You'll find I do that a lot. Okay. All right. So, don't know how I got off onto all those tangents, I guess office hours. So let me tell you something else about the book. We're starting in 1.4, okay? So therefore 1.1, 1.2, and 1.3 are all on you. That's sort of a review of anything that you might need to know to be ready for this course. So review it. Take a look at it. If there's something in there, you say, I've never remember seeing this before in my life, or I remember that, but I don't remember how to do it. Any problems you have in 1.1 through 1.3, bring them to class on Thursday or any day that you run into them. Okay? We're starting today in 1.4. And here's the reason for that. If you had read the syllabus, the course description said pre-calculus algebra, and by it goes into other things, it said, is the algebra of functions. That's where we began. 1.4, the title of that section is Functions. Okay? So that's where we're starting, and that's where we'll lead from today. I've got to turn back and get on the right section here. This is such a small podium, such a big book. Not that big a computer, but it takes up most of the room. Okay. So, functions. Anyone know what a function is? All right, we'll hit it. Well, first, the objective is to determine whether relations between two variables are functions, and we'll use function notation, which y'all are probably at least nominally aware of. If you're not, you will be very soon. Now, what is a relation? It almost gives it away here. It's some sort of comparison or relationship between two variables. Okay? I'll just make up some. Your age and your height. There's a reasonable comparison. When you were very young, you were a certain height, and when you got older, you went up in height until finally you sort of leveled out and were pretty constant. And then when you get old and decrepit, maybe you'll start losing a little bit of height. Okay. There's a relation. Okay. Here's a weird one. Your gender and your birth date. There's no apparent relationship with that at all, but you could compare your gender and your birth date. That's a fine thing to do. There's just no pattern there. Okay. Age and height. At any given age, how many heights are you? One. At 2 o'clock today, you'll be one height, okay? You can't be three different heights, only one, okay? So there is, and let's go to the other one, your gender and your birthday. Well, there's a few females in here, there's a few males in here. You all have different birthdays. So for any one gender, you can have multiple birthdays. That's a relation, sure. But a function is the first one, where for any given input, your age, you only have one output, your height. Your height, only one height at that age. Okay, we'll see other examples of that. So that's, a relation is any comparison of two numbers, a function, very special one, okay? We'll then talk about domains of function. Now, I don't want to go into all the detail now, but basically, that's your first variable. All the allowed things that you have for the first. We call that the input, okay? The output is called the range. We'll get to that later, too. We'll use functions to model and predict and solve some real-life problems, okay? So we'll be doing that. And then we'll come up with a thing called the difference quotient. And guess what? You've already done them before, and you probably never called them that, but you've done them before. So let's start with an introduction to functions and function notation. Many everyday phenomena, now the trouble is, my microphone's in the computer, so I need to talk here, but I like to move around. So if you're listening to these things, you'll find that I fade in and out some. That's because I'm moving around. I'll try to stay focused, but I like to wave the arm from the other side, but I'll try to do it from here. Many everyday phenomena involve two quantities that are related to each other by some rule of correspondence. We just gave a couple. The mathematical term for such a correspondence is called a relation. Anytime you have two quantities that somehow are related to each other, maybe very, very, third cousin twice removed. I don't know, it's not a very close relation, but some sort of rule of correspondence. That's a relation. In mathematics, equations and formulas often represent these relations. Now, certainly the two examples I gave would be really hard to come up with a formula equation for those. But for the first one, every person would have a different one. But in math, and these are what we're going to be dealing with mostly. For instance, the simple interest, capital I, that's not learned, is I, earned on $1,000, I wish I had that, for 1 year, is related to the annual interest rate, little r, which is very little these days, okay? If you have looked at your, if you have any savings account, it's minuscule, okay? By the formula, here's the formula. I is equal to 1,000 r. The principal, 1,000, that's what we have here, times the interest rate. So let's just say the interest rate was 1%. I think that's generous these days. It's probably more like 0.25% or 0.5% or something really pitiful like that. But let's say 1%. So the interest earned in 1 year would be 1% of 1,000. Move the decimal two places, you get $10 at the end of the year. Boy, that you buy you a meal somewhere. Okay, so really low interest rate. At 0.25, buy you a snack. Okay, so anyway, that's a relation. The relationship between the interest and the interest rate. Makes sense, doesn't it? Now this is also, we'll learn later, a function. But we haven't hit that. I've hinted at it, but we aren't there yet. So this formula represents a special kind of relation that matches each item from one set, the set of interest rates, that's the input, to exactly one item from a different set, that's the amount of interest, and that's, we'll give it a name later, that's called the function. If you only have one output for any one input. So there's your definition. A function f, favorite name for a function, f, boy, mathematicians are very creative, by the way, okay. From one set A, we'll give that a name in a minute, to set B, we'll give that another name, right down here, is a relation, a function is a relation that assigns to each element x in the first set, A, exactly one element y in the second set, B. That set A is called the domain. Okay, we had that word earlier. That's what it is. The set of inputs, okay, of the function f. And the set B contains what we call the range, all the possible outputs you can get from those inputs. Okay? Now, here's sort of a dumb example, but seems like sometimes students will relate to it. Let's imagine you're down in the bookstore, okay? And you decide to buy a bag of chips. I think they sell chips on there, don't they? Okay, and the person ahead of you has purchased an identical bag of chips. You know, same brand, same, everything. Identical, same size, everything. And that person goes through ahead of you, and they charge them $1.19. Okay, they pay for it and leave, and then you put yours down, and they charge you $1.25. Are you a happy camper? No, because for any one input, there'd better be only one output. Okay, for the same bag of chips, you better be charged the same amount. That's an example of a function. The other would be a relation, but the function would only have one set of outputs. One output for any given input. And we'll see examples of that. Okay, here's one right here. Let's look at a function below. Now, there's several ways to express functions. We've already said equations and formulas. That's an algebraic, way of doing it. This is called the mapping, okay? And this is taking the time of day. See, I can't stand being over there. The time of day here, okay? And these are afternoon hours, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, and 6 o'clock. That's your domain. That's your input. What you're doing over here is measuring the temperature. You have a thermometer hanging out there on the tree, and on the hour, you look out there to read the temperature. How many temperatures can you have at 1 o'clock? One and only one at the position where you are. Yes, so this is going to be a function. And these are degrees Celsius. I'm sure y'all are very familiar with that. That would be approximately about 48 degrees. So it's a little later in the year than we are here. Fahrenheit, by the way. Okay? I'm just estimating that. At 2 o'clock, it's gotten a little bit warmer. At 3 o'clock, it's gotten warmer. But at 4 o'clock, hey, same temperature it was at 3. Is that allowed? Yes. For any one output, you can have multiple inputs, that have that same. But for any one input, you can only have one output. So that is allowed because it has gotten cooler. Peaked sometime between 3 and 4, and then at 5 o'clock, it got down to 12, and at 6 o'clock, 10 degrees Celsius. So that is an example of a function. For any input, one and only one output, even though you could have multiple outputs for the same input. No, multiple inputs given the same output. Okay, that's what I meant to say. Okay, kind of makes sense. Now, I remember when I was in calculus class, first term calculus, we didn't have pre-calculus. I went to Georgia Tech. They threw you into calculus. And my little rural high school in Georgia had nothing close to pre-calculus in high school. So I was sort of stuck there. Never heard the term function used mathematically before. But the professor, I had a great professor, hard as a nail, but really good. He described it this way. He said it's like a black box, okay? Let's make it a black box, okay? Okay. All right. And this black box has a chute that you can feed things into and a chute that stuff comes out of. And you have a crank over here, and you turn the crank. So you put the input in here, turn the crank, this is the function, and here comes the output out here. As soon as he did that, it kind of makes sense, a little more sense to me. Because I grew up on a farm in Georgia, and just about every winter, my father raised, we had cows, chickens, garden, pigs, just the whole works. We almost fed ourselves, not quite, but pretty close, and it was good food too. But just about every winter, tried to hit the coldest day of the year, they'd have the hog killing, okay? We'd kill the pig and, process it that day. And one of my jobs, I was a little boy back then, was to grind the sausage. As soon as he did this, lights went off because the sausage. Now, my dad, when he was cutting up the pig, after everything had been done outside, inside, cutting up into the pork chops and the ham roast and the whatever, there'd always be little scraps left over. And the scraps all got put on a pile, okay? Little bits of meat, a little bit of gristle, whatever, but it got put on the pile. It was total fat that went into the lard bin, and we rendered the lard later, okay? Y'all don't need to know all that. But anyway, it's all processed, okay? And as he was cutting and stuff, the pile of scraps kept getting bigger and bigger. And then at the end of the day, end of the thing, when everything else was packaged and stuff, then we got out the sausage grinder. And we hooked it to the table, and you put the blades in a certain way and stuff like this, and it had a spout here that you put stuff into, and then out here is where it came out. You put the pan under there. And my job was to turn the crank, okay? That's one thing I could do. Couldn't do much else, but I could turn the crank. So what they did, they took those scraps and put them in, but also put some red peppers, some seasoning, sage, and other things like this. Those were the inputs, okay? The output was a sausage. Okay, so I said, that's what a function does. It takes various things from here and spits out something there. That's what a function does. The stuff that goes in, those are elements of the domain. The sausage, the stuff that comes out is the range. Okay, so that's how I think a function. Look, I relate to food. Okay, that's my specialty. Okay, so. Time works too, and temperatures, all these things can be fine. Okay, here's another way to represent a function. You can have a mapping diagram like we did before, or you can use sets of ordered pairs. Okay, these are not food pairs, these are two numbers at a time, that pair. So here's 1 and 9, 2 and 13, 3 and 15, 4 and 15, 5 and 12, 6 and 10. Have y'all seen this before? Yes. What's the first? The time. And what's the second? The temperature in degrees Celsius. Absolutely. This is the same function we saw on the mapping, but now we set it as a set. These squirrely things here, those are called braces. The brace identifies as a set, and the parentheses identifies ordered pairs. Now, notice two words there, ordered pairs. Pair means there's two, there's always two. Later we can, in math, you'll run into ordered triplets and tuplets, stuff like that. Right now we're going to settle on pairs, okay? X, Y, time, temperature, whatever they happen to be. And the order matters. Always the times first, then the temperature. Always X, then Y. Always time, then speed, or whatever your thing are, you have to keep the order right, okay? So, this is another way, set of ordered pairs. You can represent functions that way. And here's what you look for to know if it's a function. I'm going to give this away. They don't ever say this, but this is my little thing on it. Look at the first numbers. If you ever see that first number repeated and the second number has a different number, not a function. You're absolutely right. not a function. So look at the first thing. If you ever see the first one repeated, make sure that the second number is repeated exactly too. If it's not a function. You hit it on the nose, okay? All right, for the second number to, that's fine, we said that. So here's the characteristics of a function from set A, what do we call set A? Domain, to set B, the range. Each element in A must be matched with an element in B. There's got to be some temperature out there for that time of day, okay? If there's not, the apocalypse has happened and you're dead. No, I'm sorry. We won't go there. Okay. So there has to be an element in B for every element in A, okay? Some elements in B may not be matched with any element in A. Oh, we saw that, didn't we? Let's go back here. And we see there's 1, 2. There's no cold temperatures like that, and really no hot temperatures like that, okay? You're only using a few of them. That's not really all that important, but that's true, okay? Now, 2 or more elements in A may be matched, that's in the domain, in the inputs, can be matched with the same element in B. We saw that. 3 and 4 were both matched with 15. Perfectly fine. But an element in A, the domain, cannot be matched with 2 different elements in B. Can happen if it is not a function. Okay, very good. It is a relation, but not a function. Make sense? All right. Exciting stuff, isn't it? Okay. Now, like I said, there's several ways to represent a function. Here we go, mention them. Okay? Remember when I was talking about your age and height? I said it verbally, so you can represent a function verbally by a sentence that describes how the input variable is related to the output variable. Now, let me give you, this is not official, this is just me, okay? I have this little theory that to be a good mathematician, you have to be just a little lazy. Do any of you qualify? No, oh, a few. Okay, we got some budding mathematicians. Now, you hard workers, you can still do it. Don't let that discourage you. You can still do it. But to be a really good mathematician, you got to be a little lazy. And I'm lazy enough, I don't want to write sentences every time I do a function. You know, I don't like having to write sentences. I mean, I'm not going to say about mathematicians, but you usually don't like to do English. No, we won't go there either. Okay. So verbally, you can do it that way. Ha! Numerically, that can sum it all up a lot shorter than a sentence. Okay? Numerically, in a table, now I bet you some of you have done what they call T-tables when you were graphing. You put your X's here, your Y's there. Basically, you could have been describing the function as long as the X's didn't, same X didn't produce 2 Y's. Same, different Y's. Okay? So that's in a table or a list of ordered pairs like we just saw. That's another listing, numerically, that matches input values with output values. Or graphically. We could actually draw a graph of it. That's even better, okay? Because, well, we'll get to there in a second, okay? In which the horizontal axis represents, guess what? Horizontal axis is the input, the domain, exactly. We have another name for it. We'll get to it later, but I'll say it now. No extra charge. It's the independent variable. You pick an X, or pick something off the horizontal, and then you look and find out what the Y is. The Y is independent on the X. Y depends on X, okay? Or whatever. Temperature depends on the time of day, right? Makes sense. Your height depends on how old you are, right? Okay. So, the input and output. Input is on the horizontal axis. The vertical axis represents the output, okay? Or, and this is even the best, isn't it? Write it as an equation. Real succinct, short, sweet, and you got it. You don't have to draw a graph. You don't have to list a table. You certainly don't have to write sentences. You just write the equation. Actually, guess what that equation is? It's a mathematical sentence. Oh, nice, isn't it? Because the subject is the left-hand side, okay? The verb is the equal sign, and the predicate nominative is the right-hand side. Yes, we can do that. And we said we didn't like English, didn't we? Okay. So let's see how we're doing. You know what? I forgot to bring up my watch. But but someone, I'm sure, in here will let me know if I go over, won't you? Y'all are so kind. Okay, now, to determine whether a relation is a function, you must decide whether the input variable is matched with exactly one output variable. That's the definition, remember? When any input variable is matched with two or more output values, it's not a function. That's why I said when you look at those ordered pairs, look at that first thing. If you ever see the first one repeated, make sure that the second is also repeated exactly, or else it's not a function. Same thing with the t-table. We'll find out graphically a good way to do that. Okay? We'll do this in every sense, so to speak. Okay? So here is example 1. Determine whether the relation represents y as a function of x. So the input value x is the number of representatives from a state. This is in Washington, D.C., in Congress, the House of Representatives. And the output value, y, is the number of senators from that state. Okay? Is that a function or not? Second? I heard some no's. Did I hear any yeses? Okay, the nays have? No, they don't. Okay. This is expressed as a sentence. Okay, now let's think. How many representatives does Alabama have? Does anyone know? Say again? I think about 7. Say again? 7. Okay. How many senators we got? 2. Okay. Let's pick another state. Now, I don't know this for sure. Georgia used to have 10. They probably have 11 or 12 now. They've grown a little bit. How many senators they got? 2. Okay. Let's pick Wyoming. How many representatives? Who knows? 1. One of the smallest populated states in the country. 1. How many senators? 2. So no matter how many representatives you have, there's one and only one output, 2. So guess what? That is a function. Okay? Remember, you can have multiple outputs, one output for multiple inputs. You just can't have multiple outputs for a single input. So no matter what number of representatives, you can't have more than 2, and you can't have less than 2 senators. Okay? So therefore, that is a function, believe it or not. How about this one? This is a t-table sort of thing. Is that a function? Why not? Ha! Input 2, 2 different outputs, not a function. Okay? And everybody see that? Okay. And there's C. That's graphically. So here we have our sentence. There we have our numerical. There we have our graphical. Is that a function? I heard a yes. Do the yeas have it? Yes, they do. Okay? Because give me an input. Second? 1. Okay, I'm hard of hearing. Sorry about that. And what's the output for 1? 0. Perfect. Give me another input. -1. What's the output? 0. Perfectly good. It only has one output. Give me another input. 2. What's the output? 3. Another input. -2. What's the output? 3. That's fine. Another input. 0. And what's the output? -1. Yeah, -1. Okay. All right. So yeah, that is a function. Any given input is one and only one output. Okay. Now this is what we call a discrete function. There are only 5 points on it. This one was discrete too, but it's not a function. Only 5 ordered pairs. Okay. This one, I don't know how many there are. Less than 50 because there's 50 states, but some of the states could have the same number of inputs, but they all have 2 outputs. So anyway, those are discrete sets. Okay. Now, if this had a line connecting all of these, that shape is generally, anyone know the name of that shape? A parabola. It looks a lot like, and it is a parabola, okay? Okay, would be a parabola, okay? Now, could you list, if that's all the points in between here, can you list that in the table? No, you only list some. Because how many points are there between 0 and 1? Infinite number. Because no matter which, there's 1/2, 1/3, 1/4, 1/5, 1/6, and that's just a half, there's an infinite number of points. If you had a continuous function there. So therefore, graphs do continuous functions far better than tables do. Tables can give you a few representative quantities, but then you connect the dots, like you used to do in grammar. Okay. So there's example 1. Let's see their answers. The verbal description does describe a function because regardless of the value of x, the y value is 2. We have a name for that. That's called a constant function. Because no matter how many representatives you have, number of senators is always 2. That's a constant function. Okay? Second one, table does not describe a function because y'all picked it out. Number 2 is matched with 2 different outputs. It can't happen as a function. Relation, yes. Function, no. And the graph does describe a function. Each input value is matched by one and only one output value. Okay. How are we doing on time? Second? 41. Oh, we got more time. Okay. So, representing functions by sets of ordered pairs is common in what we were calling, I already said it, discrete mathematics, where you have just a finite number of points. Okay? Now, if that finite number is huge, then that gets a little awkward too. But you can do it. In algebra, however, it's more common to represent functions of equations or formulas involving 2 variables, and you have no limit to the number of ordered pairs. Here's a function. This is your algebraic expression. Remember, we had sentence, we had table, or numerical, we had graphical. Here's our algebraic. Boy, isn't that condensed. Okay? Y is equal to x squared. Give me an x. 5. What's y? 25. Give me another x.
6.
Second? 6. What's the y? 36. Okay? Any x you want to choose. So guess what? What's the domain of that function? All real numbers. You could do a negative 17. I don't know what its square is, but it would be. Oh, but what would be the range of that function? Only positives, because you square a negative number, positive. Square a positive number, positive. Okay? And 0. Square 0, you get 0. Okay? So yeah, and guess what that'll be? What shape? A parabola. You got it. Okay. Okay, that would be a parabola. Represents the value y as a function of the value x, variable x. That equation, x is the independent variable, because that's what you get. Give me an x. I feel like a cheerleader, right? Okay? And then the dependent variable is what you get when you put the x in the function. Okay? Now, I'm going to say this now. I'll say it about 4 million times for the rest of the term. Okay? If you remember this, you've got function pretty much not. Y is a function of x. If you remember that you got it not. Okay? We're not there yet. But y is some function of x. You put in the x, that's the input, you turn the crank, and you get the square of it. That's what the function does for you. It squares the x. It makes the sausage. Okay. All right. How are we doing now? 44. Oh, we got another minute. Okay. The domain of a function is a set of all values taken on by the independent variable x. The range, then, is a set of all values by the dependent variable y. Usually easier to do the x first and think about it. And you always start assuming this. Can it be all real numbers? Sometimes it can't. But you always start and see if it is. If it can't, you have to chop it off somewhere and say, well, it's numbers between here and here, or something like, or here, or there, or here to there, something like that. But then once you've determined that, then you try to determine what the y values are. Sometimes it's all real numbers, sometimes it's only non-negative numbers, like we just saw. So we will be doing that next. I take it we're about out of time. Is that right? Let's see where we got to. Oh, they skipped example 2. Shame on them. We will begin with example 2 next time. Oh, are there any homework exercises? Oh, you thought you'd get away without it, huh? Let's see. I think you could do any of the odds, 5 or 7, either one of those. And you could do number 9. And we'll stop there and we'll pick up the rest of them as we do example 2. Okay. Good deal. Odd numbers, yeah. There's only a few. It's on page 44, 5 and 7, and number 9. Okay. So it's only 3 possible ones there. 5, 7, and 9. Yeah, on page 44.
Page 47.
44.
Page 44.
Huh?
You turned around for last time.
Did I do what?
You turned around for last time.
The Miss Martin gave me one. Okay. She what? Okay. And what's your name? Second. Davis. Huh? Okay, say that. My hearing's so bad. Collier. Oh, there you are. Jayla. Okay, I know you. Okay, you did come in last time. Okay. I'll try to get that changed when I put the roll in this time. All right, thank you.
Did you add us to the roll?
No, I took you off. I wanted to kick you out of class. No, I have you here, I think. Cole and Ryan Harmon.
Thank you.
Okay.
Is there anything important in particular that we missed?
I wasn't here either. Do look at the YouTube videos that you get through Blackboard, under handouts, PowerPoints, and more, and it's right at the top. Look at the first 2 of those videos, the one that says syllabus and whatever the other one says. Okay.
You said page 44 odd numbers?
Yeah, only the first few odd numbers. Okay, starting with, let me find it again. Okay, 5, 7, and 9. That's all you can do.
So we just trying to get.
No, you just do this for your own practice. Yeah, your own cultural enlightenment. Okay.
And we get the book from,
Huh?
we get the,
Okay.
it's online.
Yeah, well, yeah, I don't know if you can access it yet or not. I've got to get with them and see if I have to set up a WebAssign. I don't ever use it, but I think I have to set it up for you. But try it, see if you can access
So
it.
we get the it's like a card or something that we get from the bookstore.
When you pay for the $120 or whatever it is, they give on your receipt. There's a number. Okay, if that won't do it alone, then you'll also need the class code, and I'll give you that when I can get it from Cengage.
Okay.
Okay. And it maybe you can get Terrell's and use his, cause possibly. I don't know. I don't know if he did it or not. Okay.
I will see you Thursday.
All right. See you Thursday.